Hey guys, I'm back and continuing 5 examples in 5.3. I'm looking at page 275, number 8 now. It asks us to determine the equation of the line perpendicular to the tangent line to the function f of x equals 1/2 e to the x. Let me write that down. 1/2 e to the x at the point x equals ln 3. So first thing, when we want to determine the equation of a tangent line, or the slope of a tangent line in this case, because we want the equation of the line perpendicular to it, we always need the derivative, right? I can hear you all answering my question about that and telling me that whenever we're doing the slope of a tangent line, we always need the derivative as our first step. So f prime of x in this case is actually exactly the same as the original function because according to your useful list, f prime of x when f of x is e to the x is the same. F prime of x is e to the x, and the coefficient just stays in front. To get the slope of the tangent now, we would just substitute in the value of x into the derivative. So 1/2 e to the ln 3. And also from your useful list, you should recognize that the property e to the ln x is equal to x, so I can replace e to the ln 3 with 3. Oh, I'm just going to continue with this green color. It's a little bit annoying switching the colors, so once I switch, I just stay. I don't go back. So that means that my slope of the tangent is 3/2. If I want the line perpendicular to this line, then what do I need to do? I need the perpendicular slope, which would be the negative reciprocal. And so the slope of the line that I'm looking for will have a slope of -2/3. Let's go on to the next page, bring that perpendicular slope over with me, as well as my x equals ln 3, x value of the tangent point. And now I need the y value of the tangent point, and so I will simply substitute ln 3 into the original function. Let me just go back and get it here. 1/2 e to the x. So 1/2 e to the ln 3 just so happens to be exactly the same as the slope of the original tangent line because the derivative is the same, right? So therefore my tangent point is ln 3/2. Now to get the equation of this line, and my slope is, perpendicular slope is -2/3. To get the equation of this line, I can either use point slope form or y equals mx plus b, as I've said many times in class. As you know, I prefer point slope form, so I'm going to use that. You can easily use y equals mx plus b as well if that's what you prefer. So y minus my y value of the tangent point, which is 3/2, equals the slope of the perpendicular line, which is -2/3, times x minus the x value of the tangent point, which is ln 3. And then I'm just going to do a little simplifying here, and I'm simply going to expand here and bring this constant over to the other side. So I'm left with y equals -2/3x plus 2/3 ln 3. Sorry, I got a little messy there. Plus 3/2. So that is the equation of the line that is perpendicular to the tangent line to the given function.